Hi there, this is Penelope. This is a short video just trying to help you figure out which trig identity to use. Now, some of these are reasonably simple, but at least it gives you the thought processes that you need to go through. A lot of the time, you can change everything just to sine and cosine, and then it becomes a whole lot easier. Then you can use identities if you can, but what you need to do is you work with the left-hand side. Don't try and rearrange it and combine them. Just work with the left-hand side, then go as far as you can, then work with the right-hand side, and then if you end up with the same thing, then you've proved what you've set out to prove. So let's have a look at this one here. Let's start with the left-hand side. And just remember, the very easiest of trig identities is the one that says cos squared theta plus sine squared theta equals 1. So on the left-hand side, tan we can replace with sine squared and cos squared. So we'd say sine squared theta over sine squared cos squared. So I might bigger one of those. Sine squared theta over cos squared theta. And then if I do that division, it becomes sine squared theta. Now we're dividing by a fraction, so we flip and multiply. Okay, cancel, cancel. And we're left with cos squared theta. Not exactly what we were looking for until we remember that from the very important trig identity, cos squared theta equals 1 minus sine squared theta. So our left-hand side equals our right-hand side. That's what we were trying to do. This one. Again, let's put everything in terms of sine and cos, and let's also remember that cos squared theta plus sine squared theta equals 1. Okay, on the left-hand side, cot squared is cos squared over sine squared, and cosec is 1 over sine theta. So if we do that, that's a fraction divided by fraction. So we need to flip and multiply. And one of those cancels out with one of those, so we're left with cos squared theta over sine theta. Well, maybe that's as far as we can go on that side. So let's have a look at the right-hand side. So we've got cosec theta minus sine theta, which is, okay, cosec is 1 over sine theta, and then minus sine theta. To go any further, we're going to have to put them over a common denominator. So the 1 is just there. Sine theta is over 1, so we need to multiply it by sine theta, so we get 1 minus sine squared theta. And remembering, 1 minus sine squared theta is cos squared theta. We have what we were looking for, cos squared theta over sine squared theta. Therefore, we've done what we were trying to do. Next one. The next one's a generalized technique, and there's a video on Podia about doing this from the American guy. What we can do often when we've got 1 minus on the bottom is we can multiply by its conjugate. So on the left-hand side, we'd have sine x over 1 minus cos x times the conjugate, which is 1 minus cos x over 1 plus cos x over 1 plus cos x. and then that's sine x times 1 plus cos x. And you should recognize by now that if you multiply the bottom line together like that, you're going to get 1 minus cos squared x, or theta, whatever we've got, theta, x, not theta. Now remember again, cos squared theta plus sine squared theta equals 1. So 1 minus cos squared theta equals sine squared. So I've got sine x over 1 plus cos x over sine squared theta. I keep wanting to say theta, sine squared x. And we can cancel one of the sines with one of the sines, and we're left with 1 plus cos x over sine x. That's exactly what we wanted. For the next one, we already know from the list that there is a relationship somehow between sec squared and tan squared. And if we look up our list, it says that 1 plus tan squared theta equals sec squared theta. So we can substitute that in. On the left-hand side then, we would have 2 minus, now instead of sec squared theta, we would have 2 minus 1 plus tan squared theta. So that's equal to 2 minus 1 minus tan squared theta, which is 2 minus 1 is 1 minus tan squared theta, which is what we were looking for. Bingo. Now the next one's a little bit harder, but not really. For this one, we need to remember that cos of negative x is the same as cos of x. And you can just check that, or you can go back to where we talked about odd and even functions, and also that sine of negative x is equal to negative sine x. Okay, so let's substitute those in. So on the top line, we're just going to have cos of x, and on the bottom line, we're now going to have 1 minus sine x, just using these two facts. So we can use the conjugate trick again. And the bottom line, or the top line, is just stays the same for the moment. And then the bottom line, 1 minus sine, 1 plus sine gives us 1 minus sine squared. And we know cos squared plus sine squared is 1, so that becomes cos x over 1 plus sine x over cos squared. Okay, and we can cancel out one of the causes with one of the causes, and we are left with 1 plus sine x over cos x. Now that doesn't look like the answer, but what if we do this? We divide each of the terms by cos, so say 1 over cos x plus sine x over cos x, and 1 over cos is sec, and sine over cos is tan. Done. The next one starts looking at double angle formulas. And here, which one do I choose? There's only one trig identity that goes number, sine, cos, right? And it's the one that says sine 2 theta equals 2 sine theta cos theta. Okay, so we don't have a 2 there. We have 7. Sorry, we have 14. So let's just multiply that by everything by 7. So then we've got 7 sine 2 theta equals 14 sine theta cos theta. Okay, now this time I'm deliberately mixing up my thetas and my x's because we're not quite right. We have 14 sine 6x and cos 6x. Close to the edge of the page, yes, cos 6x. Right, what do we need on the left hand side then? What we've done is we've replaced theta from here to here. We've replaced theta by 6x. So we had 7 sine 2 theta equals 7 times 2 sine theta cos theta, which is equal to 14 sine theta cos theta. So 7 sine 2 theta. So let's go, let theta equal 6x, because this is what we had. We had 6x and 6x. So our right hand side would be 14 sine 6x cos 6x, which was the question. And then the answer would be 7 sine. Now, if theta is 6x, then 2 theta must be twice times that. So the answer is 7 sine 12x. And the last one I want to look at, and here is this one. And again, the only identity that has cos something times sine something is the one that's got 2 sine A cos A. And if you check that out, that's sine 2A. Now, we don't have a 2 on the right, on what we're trying to simplify at the moment. So what if we just go sine A cos A equals a half sine 2A. Okay, what if we reorder this so that it matches? And on the left hand side we've still got a half sine 2A. Right, make the comparison. Let A, or say A, equals 9 over 2 theta. So our right hand side then becomes cos 9 over 2 theta sine 9 over 2 theta. Better do the same on the left hand side. So that's a half sine 2 times 9 over 2 theta. So that left hand side now becomes a half sine 18 over 2 is 9 theta equals cos 9 over 2 theta sine 9 over 2 theta. So this is the answer that you were looking for there. That cos 9 over 2 theta sine 9 over 2 theta simplifies to a half 9 over 2 theta. Okay, hope that helps.